we have some people who criticize the rope model, some of these flatlanders, right? We're today's flatlander day, okay? And one fellow says, and this is a very common question, I like to put this up there because these people really, they start off on the wrong foot. They're not even qualified to ask questions because they don't even know what to ask. And so they ask one of the dumbest questions ever. And here it is. It says, ropes are made of what? Ropes of what? What are the ropes made of? People ask this stupid question. And you say, well, are they that lost? Go to the hardware store and ask for a 2-strand rope. And when you get it, you'll get something like this, right? What you see there. It's made out of 2 threads, 2 strands, 2 wires, 2 strings, whatever you want to call them. And they're wound around each other. We call this a rope. Was that so difficult? Yeah, a rope is made of 2 strands. I'm sorry that you never heard of that you never learned this in kindergarten. Maybe you flunked kindergarten, I don't know. So we have to show them how our theory is constructed, okay? And our theory says that this is all that exists in the universe, a single closed loop thread. This is not the real thread, okay, by the way. This is just a simulation of what we're proposing, okay? We're saying, let me remove this here for a second. We're proposing that this is all there is, ultimately, okay? A single closed loop thread. You can simulate it with a rubber band if you want to explain it to a kid, okay? That's all there is. This thread turns into every atom and every rope that interconnects any 2 atoms. That's it. See how simple? We live in a very, very, very simple universe. Okay, I know you've been taught otherwise. You're saying we have a complicated universe. We cannot understand anything. We'll never figure it out. Science is an ongoing process of discovery where we don't discover, we never find, we only seek. No. At some point, the buck stops here. You have to explain. And to explain, you have to have foundations, definitions, and the objects that you're going to use to explain your theory. Okay, that's the way it works. Your mechanism, you're going to explain a cause. Okay, so this is the starting point, and this is more or less what it looks like. Here's a synthesis of that, okay, for those of you who are new to the site. Okay, here it is. We have the single closed loop thread, which is the rubber band I just showed you, okay? It twines around itself, all around the universe, and it creates that universe that you see on the upper right-hand corner. All atoms in the universe are physically connected to all other atoms in the universe. All these atoms form galaxies, stars, planets, asteroids, comets, everything you can think of. Even the gas that's interstitial, between galaxies, interstellar, intergalactic, all that stuff. So we're saying all this, if you were to unwind that entire universe that you see there, it would look like that single closed loop thread on the upper left-hand corner, okay? So this is what we're proposing. This is what we're saying the universe is. What's the black stuff in the background? That's known as space. What is space? Space is nothing. What is nothing? It's the opposite of something. What is the opposite of something? That which has no shape. Okay, so space has no shape. Space is nothing. Nothing is a concept. Okay, do we have that? Nothing is a concept. Okay, and no, matter is not really floating in a concept. Matter is simply related to matter. Okay, it's not related to the background. The background simply forms this backdrop that kind of chisels, you could say, matter. We're only concerned about matter, not about the black stuff, because the black stuff is not there. Okay, it's not a thing. Okay, it's not a container. Okay, so what happens with these interconnected atoms? Well, there you see it on the lower left-hand corner. It's in a dynamic mode. You have the 2D version and you have the 3D version. Okay, of the atom, the simplest atom, which is an electron shell that encapsulates the proton star. They're connected by a rope, and as the atom expands and contracts, it torques the rope, and that is known as light. Okay, that's the, in a synthesis, that's in few words, that's what the proposal is. Okay, that's what we're proposing. That's how the universe works. That's what light is. And here we have the construction of the atom, okay, so that you can see it better. Okay, you have 2 threads. One twines around and encapsulates the one in the center. That comes from every atom in the universe. It's a little star in the center there. Okay, so you have all the ropes in the universe converging upon our atom. They all crisscross in the center, and they form this entity which, as you can see, has ropes converging upon the edge, the electron shell, as we call it, and one of the threads goes around, the other one goes through the center. Okay, so this is the construction of our atom. It's constructed out of the same material, the same threads that form the ropes, and we have a single closed loop thread in the entire universe. That is our proposal. Bottom left, you see our 2D atom. Here you see it bigger. That's what it looks like. Ropes converging upon the electron shell, and the one thread goes to the center of the atom, which forms all the threads from the universe, converge upon that center, and form the proton star. Okay? And immediately people think about touch. They think about our experience in our macro world, and we have to correct them there because we say that, first of all, an object is not that which you can see or touch. It's that which has shape. The rope, the atom, the threads all have shape, okay? But they do not have the ability to see or touch, especially touch, okay? They can't touch each other. They go right through each other. And people have a lot of problem with that. They say, what do you mean they go right through each other? Because it offends their everyday experience. But again, an object is not that which you can see, touch. It's that which has shape. We meet the definitions. These things have shape. The thread, the rope, the atoms, they have shape, but they cannot be touched by humans or between them. And that's a part of the foundations. People say, Bill, you're avoiding the question. You're just making an ad hoc assumption. And we have to make that assumption. We have to make that assumption because we have to explain Mother Nature's universe, not the one you want, not the one of our macro world, not the one of our ordinary or everyday experience. We have to explain why this pencil, right, falls to the floor, okay, and and you see nothing above and nothing below, and you can't touch anything above or below. And so hopefully whatever's here, right, is untouchable. And if you can touch it, that'd be great, but we can't touch it. And so we have to make our assumption, the foundation of this theory, we have to make it untouchable to mimic, to simulate Mother Nature's world. Not the one we want, not the one we say, well, how come I can't see or touch it? Well, because it's Mother Nature's world that you're analyzing. Her world you cannot see or touch, which is the mediators that cause this. And if you say there is nothing here, then you're doing black magic. You're doing everything by action at a distance, and we do not understand your mechanism. Okay, so that's the issue. Okay, another fellow brings up another issue, and again, all these are Flatlanders, the way they think, or don't. Okay, this fellow says, you state the rope connections between objects change from a coaxial to becoming spread out, increasing the number of independent connections. Exactly. In your model, the number of rope connections to all atoms don't increase, and the tension and length of the ropes remain fixed. Correct. How does changing the angle of the ropes add acceleration to an object? So I guess this fellow doesn't understand. Okay, he's never visualized this, what he's trying to figure out there. Any real physical, I like the arrogance. They say, any real world physical examples of change in angle producing an acceleration between objects using ropes of fixed length, number, and tension? Okay, so this is what he's bringing up. He also brings up the next issue, which I think it's the same fellow. He says, you forgot to draw the trillions of ropes connecting the astronaut to every star in the universe. You also have not justified why the astronaut would fall towards the Earth in the first place. Are there leprechauns pulling on those ropes? What about the leprechauns pulling in every other direction? Okay, so the first thing we have to educate this poor fellow on is Newton's equation. I guess he's never been familiar. He's never been, educated on Newton's equation. It's got a little d at the bottom, and not r like the people from mathematical physics put down there. It's not an r. It's not a radius. Okay, and there's a lot of reason for that. I've talked about that in the past. It's d for distance, always. Okay, never put a little r there like the mathematicians do. Okay, now what is it? Weight. You have weight, and you can see the weight of an astronaut, 25 kilograms there outside of the Earth, is different than him being closer to the Earth. And the only thing that's changed is distance. Okay, so he's at a certain distance at 25 kilograms and a different distance at 50 kilograms. Okay, so he weighs differently depending on simply location. Weight is a static concept, really. It's location dependent. If the astronaut moves 1 millimeter, 1 inch, 1 foot, 1 yard closer to the Earth, he already weighs more. Just by changing his location, he has a different weight. And people don't always understand that. In fact, the people who don't understand it are people from Newton all the way to Hawking. All these people who are mathematicians, they don't understand that. That weight is a static concept. Weight is location dependent. Different location, different weight. You move 1 inch closer to the earth without moving. If you could just stay there in space, you would weigh differently than if you are farther out. That's how simple it is. And this fellow doesn't understand that, and so it's very hard to talk to people who do not understand Newton's equation to begin with, okay? So here, let me show you this, okay? See if we can clarify that with a little bit. Here it is. This is how gravity works, okay? This might answer his questions. There you have a cube and a cylinder, okay? As the cylinder approaches the cube, okay, you can see what's happening with the ropes connecting one atom in the cylinder to several atoms in the cube. When the cylinder was farther out, all the ropes were on the same axis. They were one right behind the other. In other words, they were all on the same axis because the atoms are all aligned, okay? But what happens when the cylinder approaches the cube? Just by location, just by changing the distance, you can see what's happening to the ropes. They immediately fan out, and each rope is acting independently. That's what we mean by independent ropes. The ropes have not appeared out of nowhere. The ropes were not created. The ropes are not pulling. The word pull is really outlawed. We use pull for the concept known as gravity, but not for what's happening between each of the ropes. The ropes are under tension, and tension is not a force. Tension is not a pull or a push. Tension is means that no one wins the tug of war. So those ropes are under tension, which is really defined by the velocity of light, c, okay? And all that's happened here is that the ropes fan out. And because they fan out, each one acts independently. And then at the bottom, you see another simulation of what we're talking about. We're saying when the cylinder and the cube are very, very far apart, you can see all the ropes form a single coaxial. It's like we're a single rope. So distance is very important when we're talking about gravity. But as the cylinder approaches the cube or vice versa, you can see what's happening to the ropes. They fan out. And that's the acceleration of gravity. On the right-hand side, you see on top the way the mathematicians talk about a spoon. They say, well, it falls and there's nothing pulling or pushing on it. And on the bottom right, you see our version, which is every atom of the spoon is connected to every atom of the earth. As the spoon falls, all the ropes fan out. And that's the cause of the acceleration of gravity. That's what causes gravity. That is gravity right there. Okay. And here's an experiment that, not an experiment really, it's a simulation. People are going to say, oh, Bill, you're running an experiment. Okay. I want you to see, I made this device because I use it as a didactic tool to teach. Okay. This is just so that you can visualize gravity, which is what this fellow says. Tell me how you produce gravity. It looks something like this, okay? See if I can, okay? This is the device, okay? See it there, you can see it maybe better, okay? This is the device. And I'm gonna set it in motion, okay, with a little video because it's probably, you'll see it better through the video, okay? So you can see how gravity works, okay? So keep an eye on the device here. You'll see how gravity works, okay? This is what we're proposing, okay? We're saying that as an object approaches center of gravity, maybe the earth, maybe the sun, whatever, you can see what happens to the ropes. Behind the hand, they form a single coaxial, and in front they open up, okay? So when we push it forward, you can see what's happening to the ropes. They change the angles. And any rope that was on that same axis would be tugging or would be acting independently, okay? But look what happens behind the hand. They all form a single coaxial. And when you move outwards, you see the same effect, okay? So again, this is just a simulation, okay? You have Newtonian gravity on the left-hand side and what I call the linear regime on the right-hand side, okay? One more time, there it is, okay? Just to show you how this simulation works, okay? Simple device that can tell you what happens with the angles of the ropes as an object approaches the earth or maybe the sun and what happens behind it. Okay, so when you leave the solar system, you're going to enter that linear regime. Okay, it's going to be almost a straight line all the way to Alpha Centauri or the next star or whatever. Okay, okay, so this is just a simulation so that you can see how we're imitating this, how we're simulating, gravity with this, the angles, okay? And of course, when you change the angles, what you're doing is getting ropes that are now out of alignment. They're not on the same axis any longer. Now they separate, and now each one is acting separately because you have an atom at the end of each one of those ropes. Okay, so distance is a very important thing. Yeah, the moon pulls on us, but the moon is so far away, a little over a light second away from us. And so its influence on us is very little because it's almost a single coaxial, more or less. Okay, so this is how you're supposed to see it. The moon is essentially tethered to the earth. Okay, now a fellow, he brings up another issue. He says, gravity goes right through things. Well, that's from Professor Muller, which I talked about a couple weeks ago. And he says, this guy doesn't believe it. He says, like it goes through a wall? Yeah. And you never figured this out, that gravity goes through the wall. It pulls on him right through the wall. The earth is pulling on him right through the ground, the floor that he's stepping on. He never realized this. And these ignorant people, they come here and they want to teach you something, or they want to laugh. They make fun of you. And then they complain when I make fun of them. See? So yeah, they're very ignorant, very arrogant people. And he says, the object, the wall, doesn't move. You're right. Yet the motion of the astronaut on an object is affected. You didn't even spell that right. I can't find a reason and rationale, again, didn't spell that one right, in the explanation. Okay, something to do with a moving concept called angular momentum between objects? Or the wall is connected to the ground, the astronaut isn't? Again, these people are so ignorant. And this comes from Mr. Muller, who said the following. Okay, he says, professor at Berkeley, he says, every atom on the earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. It goes through things. And people should really memorize all that. They should pray every night using this prayer. Every atom on earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. And people have problems understanding what I just put up there. Maybe I should leave it there for an hour until you memorize it. Okay? Yes, this comes out of Newton's equation. You can't avoid Newton's equation. Newton's equation is firmly set in place. Okay? So, you can do all the experiments you want. You'll come up with Newton's equation. Okay? Newton's equation is right on the money. And, you're being pulled right through the floor by the earth. Every time you jump, why are you pulled downwards? Something is pulling you, I guess, from underneath the floor. Why can't you jump to the moon? And this fellow never discovered that the gravity goes right through the wall and pulls on you. Now, it doesn't pull you through the wall because there's not enough matter sideways. All the matter is underneath us, and you're very close to that matter. You're also pulled by the moon, but you're very far away from the moon. That's why you don't fall to the moon. That's why when you jump, you're pulled more to the earth than to the moon. Some of these people don't understand even these basic things, and they claim to know how this universe works. They want to teach you, and they want to laugh at you the way the ideas that you have. And they're so ridiculous because they don't even know the basics. They don't even understand the foundations. Okay? I mean, if they would have gone to high school at least they would understand some of these things, but they don't even have this basis, this foundation. Okay, and another fellow says, I wonder why the space station doesn't actually fall down and how come it orbits the Earth without propulsion. You're wrong. There is a propulsion. Okay, so the space station, the ISS, right, International Space Station, does have propulsion. Okay, and so I put in there an answer. The ISS does have propulsion. It must accelerate forward. It travels faster than the spin of the Earth. The Earth spins, and this thing goes, several times, 16 times around, 16 times as fast as the spin of the Earth. It goes through the top of your house 16 times during the day, while the Earth, the cloud that would go all around would go just with the spin of the Earth. Okay, so yeah, this goes faster than the spin of the Earth. It travels around the Earth around 16 times faster, right? The ISS is a kite. Let me repeat that. The ISS and every satellite you see out there is a kite. Every probe that's ever orbited the Earth the shuttles, kite. They're all kites. Every single one is a kite. Every single atom of that device is stuck to every single atom of the Earth. That's what's keeping it in orbit. But if it just stands there, it'll fall to Earth, like, just like this. If this is just, if it stands still, it doesn't move forward, it'll fall. But if, like Newton said, if this moves forward and moves at a fast enough rate, fast enough speed, then it'll stay in orbit. Newton showed this 400 years ago. Come on, guys. And so every atom that comprises the ISS is bound by electromagnetic ropes to every atom that comprises the Earth. The Earth swings the ISS around, okay, like this, okay, like a boy swinging a ball at the end of a string. And here I'm going to illustrate that for you, okay, a little bit. Here's the ISS just standing still. This is the version that mathematical physics would show you. They say, look, the ISS is just for no reason whatsoever, just up there, and it doesn't fall to Earth. And for some reason, we have to accelerate it, propulsion, okay? And what we're proposing, we're saying, no, this is what's happening, okay? That's the real thing. We just can't see those ropes. You can't see or touch them. That's what's holding onto the ISS. That's why the ISS does not leave the Earth, okay? So that's the issue. And here you see, okay, this is what you're seeing there is the ISS going out around much faster than the Earth. The Earth spins around, and you can see that, the ISS just goes much faster than the Earth. It's like a boy spinning, again, a ball at the end of a string. That's everything works like that in the universe. The Earth is also swung around by the sun. The moon is swung around by the Earth. So on down the line, we're swinging the ISS around. That's why it doesn't leave the solar system. Why? Because what did Mr. Muller say, Professor Muller? He said every atom of the ISS is bound to every atom on Earth. Every atom on Earth is bound to every atom of the ISS. Got it? So the Earth swings the ISS around like a boy swinging a ball at the end of a string. And here you see it a little bigger. I put it up there so that you can see it better. Give me a second here. There it is. I thought I had it right. Give me a second here. There it goes. Okay, so that's what's happening. Okay, the ISS is a kite. That's all it is. It's being swung around the Earth as the Earth rotates. Simple. That's our theory. Okay. Any questions? Put them there, and we'll address it next time. Those are for people, Flatlanders, who don't yet understand what the rope model is all about.